Hello and welcome to this video. In this video, we would be discussing about the network security aspect. So last video, we saw how we can restrict a user from executing a specific API call or authenticate that user and then authorize that user for a specific set of actions. But when we are talking about application talking to each other, all the pods present in the cluster can talk to each other. They are not isolated. They accept traffic from any source within the cluster. But normally how it happens, if I have a front-end application and I have a back-end application, I whitelist the IP address of my front-end in my back-end. And I make sure that when the request is coming to my back-end database, it is only coming from that particular front-end server. So we will have to implement network policies to restrict the traffic which is being allowed as an incoming traffic to a pod, or to restrict a traffic which has to go out from a specific pod. So we can create some set of rules and we can specify what sort of traffic would be allowed to a specific set of pods or a single pod, or what sort of traffic can originate from a pod. So there can be two types of traffic, right? Ingress is the incoming traffic and egress is the outgoing traffic. So you can create policies, you can define rules which will restrict the outgoing traffic and which will have conditions and restrict the incoming traffic to a pod. So when you create a policy, you can specify a group of pod or a normal one single pod which can communicate with the other one. And you can specify that, or else instead of using the pod labels and all, we can even specify a range of IP addresses from which I can expect a packet to come up. In this way, what I'm doing, I'm isolating a pod and I'm saying that when the incoming traffic is coming, it is coming from only from specified IP address or from the specific subnet or from a specific pod itself, right? So you are attaching a policy and restricting the incoming traffic or restricting the outgoing traffic. As soon as you attach a policy to a pod, only whatever is allowed would be allowed, rest everything gets denied. So what am I saying? That by default, all is allowed. If I have pods in my cluster, default policy is to allow all. This is default policy. But as soon as you create a network policy, kind network policy, and attach to a particular pod, you say this policy would be working for this particular pod. So whatever you allow here, that only is allowed. Rest is all denied. So unless and until you have a policy, everything is allowed. As soon as you implement a policy for a pod, then only whatever you specify is allowed, rest all is denied. So we have to be very sure what we allow, and because if we don't allow something, it will be falling into the default denied case. So let's look how do we define our network policies. So this is a kind network policy. It has an API version on which the network policy kind was introduced, a metadata associated with this network policy. That is the name of the policy. I am saying I would allow hello allow from foo. So I'll be allowing a traffic from a specific label to a specific label of the pod. And in the specification section, I can specify the policy type. Either a policy can be ingress type or a policy can be egress type. So this is a ingress policy. In the ingress policy, I can specify my condition. In this condition, I'm saying I'm selecting the pod which has label as app hello. So this policy is applicable to the pods which are labeled as app hello. And what is the policy? Ingress policy here specifies that I would allow traffic from pods which are labeled as app foo. So pods which are labeled as app foo can only send traffic to pods which are labeled as app hello. app hello will not accept traffic from any other pod apart from pods which are labeled as app foo. So here if you say that this is the type of the policy and this is the rule inside the ingrace policy, from section denotes that it is coming from, and here in the ingrace I'm saying this policy type or this ingrace policy is applicable to this particular labeled pod. So this policy is applied on app hello, but it would accept traffic from pods which are labeled as app foo. So this is for the incoming traffic. If we have a similar way to define the outgoing traffic, the packet which is originating, then I can say whom I can send packet to. So here if you see, for foo to send packet to app hello, by default it can send packet to anyone unless and until a network policy is created. But if I have created a network policy, because hello is expecting packet from foo, I should allow the outgoing packet from the foo type of applications, right? So here it is again kind network policy. You have the API version, the metadata has the name of the policy. And in the spec section, instead of ingrace policy type, this time you have the egrace policy. And here the egrace policy which you see, it says I'm selecting app foo type of labeled pod. And app foo can send packet to here. It can send packet to pods which are labeled as app hello. So app hello is expecting packet from foo and foo is saying I can send only to hello. So both the sides are fixed. Ingrace is also fixed in the hello type of application and egrace type is fixed in the foo type of application. So this is how you can specify your conditions in the network policy section. Either it can be an incoming condition or it can be an outgoing condition. Depending on that, you specify the policy type. For incoming traffic, it is ingrace policy, and for outgoing traffic, it is an egrace policy. You can also say a section of the entire IP address which you would like to allow, or a subnet you want to allow. All those things also can be specified. How to secure our pods by implementing network policies for our applications. So we can restrict incoming and outgoing traffic to and from a pod. So we would set up sample pods and see how does they communicate between them in case we are implementing some traffic. So to start with, we can run a simple web server application. Here I am not taking the effort of writing that entire YAML file. Rather, from the command line itself, I can spin up pod. So I'm doing that. I'm saying kubectl run. It's very similar to the docker run statement. And the name of the pod would be hello web. It will have a label called as app equal to hello. I'm picking up this image of it, and it has a port number for the container, which is port 8080. You did not run entire kubectl expose command as well. As soon as you say -- expose, this single command will create a pod and would expose a service as well. Both of them. It's like 2 in 1. So let's pick this, and because here -- expose, it will create a service of cluster IP type, and it will pick the label, the port number and all according to the port number of the pod. So I'm creating a pod with hello web name, and the name of the label of the pod is app equivalent to hello, and I have created service as well for exposing it. Let me say get all. I should have a service, a cluster IP type of service, and an application pod up and running. Now, if I want to create another pod and I want that particular pod can only talk to ingrace, app hello would allow packets only from the other application which we are planning to spin up. And that other application pod has label as app foo. So we would create this network policy file. Till the time you create the network policy, as we knew, all pod can talk to every other pod in the cluster. But once you have implemented a policy, whatever you have given as ingrace only from such labeled pods, or in case we want to give the subnet range, the IP address, only from that range or that particular IP, the packet would be allowed. So you can see that API version for the network policy, the metadata, it has the name for the network policy. We are saying hello, allow from foo. So here you are giving the specifications. Inside the specification, you have the network policies. There are multiple types, the ingrace. In ingrace, you have the pod selector. You are saying this ingrace policy is applicable to pods which are labeled as app hello. So whatever pod we have created, it is applicable to that. And it can accept packet ingrace from only pods which are labeled as app foo. So after this, it will not accept packet from any other pod other than app foo labeled pod. So let me first create this. So this is created. You can do a kubectl get network policy and list the policy as well. I've created that. I want to create a pod whose name is not app foo, rather something else. So let me quickly create this. This I am doing to validate that the failure would get triggered. So I'm creating a pod which has label app other. It's not having the app foo label. It is having some other label. And the name image is given the restart policy. In case I stop this container, the pod, it will get removed. I go interactively inside the terminal and I'm naming the pod as test1. So once you do this, you would land into the terminal of the test1 pod. And I would try to do a wget. What is the name of my hello web pod? It is hello web, right? I can address hello web because I'm there in the same namespace. In default namespace, I can address my pod with the name itself, only with the name. So here you are saying wget and you are saying the timeout period is 2 seconds. You're trying to do a wget for hello web because it was listening on port number 8080. We are giving 8080. This guy would get timed out because we are not allowing incoming packets ingrace from pods other than app equal to foo. So I'll exit from here. So no tension at all. Once you exit, the pod would get terminated and removed because we have given the -rm option. Let's create a pod with a label called as app foo then. Once you create that, let's try communicating with the pod labeled as app hello and we should be able to communicate. I'll copy the wget command. Here I'm trying to access the hello web's web page which is serving and you can see that the host name and the version is shown up over here and it says hello world. The name of the web page content is shown. So packets only from application which was labeled as app equal to foo was allowed, with app equal to hello was not allowed because we had created a network policy and that network policy denied all the packets coming to app hello apart from when the packet comes from app foo. So this was all about the incoming traffic. Let's see how do we restrict the outgoing traffic from a pod. So we have already created a network policy. Let me quickly show you the content. It would allow traffic from app foo, but it will send it to only app hello. And it can send from port number 53 alone. So it is sending outgoing traffic conditions we are setting up. We are saying that the name of the policy is foo allowed to hello. And we are saying this policy type is egress. That means outgoing traffic. It is applicable to pods which are labeled as app foo. And in the egress section, you are saying you can send to only pods which have the label as app hello. And this is the port section. I can send this type of traffic from port number 53. Let's quickly create this. You can do apply or create, either or. Both the things can be used for doing that. Let me do that and let me check the policy kubectl get network policy. It should have policy app hello app foo. Cool. You can even describe that sometime when you get time. You know, these actions you can do on any type of resource. You can try out that as well. I would say network policy and I would say foo allowed to hello. And here if you see, it is saying that I'll send to this and traffic is restricted to any port number and all that is given over here. So here we are trying to send packet from the foo labeled application in this, right? So let's quickly spin up a test. I'm just setting up a pod which doesn't have hello as label. It has hello 2 as label. And I'll just start that particular pod. This pod is created. Pod is up and running. I should be able to create a pod called as app foo, and from there I should either be able to send packet to hello 2 or hello. We would see that. Because we have written a constraint in the network policy, it will not allow me to send it to app hello 2. So here it has started, and if you see, I am into my foo application, right? App equal to foo type of container. I'm inside that. And from here, if I do the wget command, I should be able to reach hello web type of application because that is having app as hello label. And the second one is not hello web, it is hello web 2. So let me do that, and this will time out because this guy doesn't have the same label. Label is app equal to hello 2. So from foo, when I'm sending packet to this, it is going because it is having label as app hello. Here it is not going because I'm having the label as app hello 2 over here. So with this, we see that we are able to restrict the outgoing packets as well. Let's quickly delete these applications and delete the pods as well, so that next section we have a clean one. So here I'll exit from this container. As soon as you exit, this pod will get deleted because we have given -rm. So delete this network policies and delete the pods which are up and running with the help of these commands. Do delete that as well. If you do get all, you should find those pods. You can delete this hello web pod and hello pod, both hello web and hello web 2. So let me quickly say kubectl delete. I'll not give -f. I'll delete the resource itself. It'll take a while for deletion. So let me press Ctrl+C and let me delete this. And same way you can delete the service as well. So here just change the pod to service and delete the corresponding service as well. So now your cluster should be clean for carrying out the exercise for the next one. I'm left with service of hello web. So let me delete that as well. So now it's done. So this was all about restricting the incoming and outgoing traffic from a specific pod. With the help of network policies, we are restricting or applying some constraints. So we have discussed about how to have a cluster level security by enabling RBAC. We also discussed about how to get network level security by implementing network policies. But application is running like a Linux process inside a container. So security in terms of container, that is also important. We need to provide proper access to the container so that it doesn't have the extra privileges of executing any tasks on the operating system level. So when we talk about security context, it is actually security context on the container level or the pod level. I can have a common privileges defined on the pod level, which would be applicable to multiple containers inside the pod, or even I can set some privileges or conditions on the container level as well. So when I say that I can set some conditions in the Docker section, we had understood that as soon as we create a container, we log in as a root user inside the container. But if you want to define a specific user inside the container, in the Docker image itself, you can specify which user you want to be with the help of the Docker file, right? So you can grant permissions to access a specific file, a specific object, just based on a user ID or a group ID. I can say that inside the container, my user number would be 100. And whatever access is given to user 100, that access would be available inside the container. So we can change to a specific user or specific group inside the container. We can also run a container as a privileged user or an unprivileged user. We would see what advantages do we get when we talk about privileged user. Like by default, a container is not given access to any of the devices which are connected on the host, right? But as a privileged container, when you are spinning up a container with a privileged user, you get access to those devices on the host. So there are some advantages of running as privileged users. So when we say we have privileged users, all privileges are not given to the root user, even though it is root user. If I say privileged user, then that has much more privileges than the normal root user, which has the user ID 0 over here, right? So let's understand there are simple samples which I have collected, around 6 samples, to understand exactly how can we define a security context. We would start from the left. On the first section, first snippet, if you see, kind pod definition. Inside the container, you have written security context and you say run as user 405. So this particular container would be running, and inside that container, the process which is running, that would be running with user credentials of 405, with user as 405. So when I'm specifying a specific user, it will pick up that user. Come to the next snippet. In this, I'm saying run as non-root user, right? So I'm saying run as non-root user as true. That means run as any user, but not the root user. So your user ID can't be 0. Apart from there, whichever user ID is there, that's still okay with it. If you see the third snippet, in the third snippet, I'm saying that this is a privileged container, but just by setting up a parameter called as privileged is equal to true. With this privilege, I can go and modify network stack or any other operating system level parameters within this container. If I'm within this container, I have access to the OS level because I'm a privileged process running on that host machine. I have the access capability of modifying the operating system parameters too. If you see this, few other snippets are given. If I want to change any parameter and I don't want all the capabilities to be given to this container, the leftmost, if you see security context, I'm saying capability, you just add one capability that it should be able to change the system time. So this particular container will run as root user only, but it will have an extra capability added as systime. Now coming to the next one, how you're doing an add of the capability. You can even drop the capability. Like I would say you would run as a root user inside the container. You can do anything, but you can't do a change ownership command execution. So if I want to change ownership of a folder, of a file, I'll not be able to execute as a root user inside that particular container. If you see the last one, the last snippet, in which we are mounting the root file system, and here we are saying read-only root file system is true. So whenever the container is starting, we have the file system associated with that container's image, the base image, we are saying that that file system, whichever is there, that is also read-only. I am not having any access permission to write on that file system. So it would be mounting containers root file system as read-only. So this is also a type of security constraint which we are putting. So here, if you see, we are trying to mount two things. My container would be able to write to this mounted volume, which is a empty directory type of volume. Here, if you see, my volume is empty directory, and that I'm mounting in /volume. My container can write to /volume, and here read-only is false. That means I'm able to write. But to the file system, normally as soon as the container start, we used to do ls and check few of the stuffs. In that file system, the container is not allowed to write anything. It's a read-only file system. So these are the few ways in which you can secure your containers by defining your security context inside the container's definition, or you can even write that in the pod's specification section. How do we define security context? Using different types of users, we would be setting inside our container and trying to secure our container. Let's understand, like if I run as a default user, what capabilities do I get? If I run as a non-root user, what do I see the difference? If I run as a privileged user, what do I see? So here, if you see, we are just starting in the beginning with the default one. This is how we were running or executing a command to create a standard pod, right? Where I have not specified any context and all that. So let's create a simple pod with default settings, or the default user, I would say. Default user is the root user. I'm creating a resource with that. And once you have created a resource, you can just check what is the ID of your particular user inside the container. So if I say exec, we had seen in Docker exec, it will connect to the container and execute a command for us. So I'm saying that execute this command in this pod, and the pod name I've given, because this pod has a single container, it will go inside the container and execute the command as ID. And if you see, the user ID is root, and this guy is like a root user in that particular container. Let me quickly do a clear and have this output again captured so that we can compare it sometime later. Now, with the help of another file, I am trying to create a pod, but this time I would not run as root user. I want to run as a specific user like 405. So here, this is the file and this is the content. Same, exactly, pod, container name, the image and all. But in the security context inside the container section, you are saying run as user and you specify the user ID. So here, let's create this. And once that container is created, let's go ahead and execute ID command in that as well and see the difference. So I will have to give the name of the pod. So let me quickly pick the name of the pod from the command output of the above command. This is the name of the pod which we have created, and press ID. You would see that you are working with user ID 405. So you are no more a root user. So you don't belong to any of the groups either. You can see you just have a group ID of 100 over here. But here you could work with these groups as well. You don't have access to the standard permissions or the grants which the root user had. So this is if I spin a container with a specific user, I'm just confined with the roles and actions that specific user can perform. This we have seen. In case I want to start a container with a non-root user, what's the difference between a user with 405 and a non-root user? In that case, I'm saying that I have to be user 405. Now I'm saying keep me as a non-root user. Any user ID should be okay for me. So only difference in the security context, you are saying run, instead of run as user, you're saying run as non-root. and you're giving it as true. Let's spin this particular pod, and after that we will describe and we will do a get pod and see how does that look. So here the pod is created, kubectl get pods. It's not able to run because that particular user doesn't have the capability to pull images as well. So let me describe the pod and give the pod name along with it. Here, if you see, the Alpine image which we wanted to pull to spin up that container has non-root user and the image will run as root user. So I am unable to pull the image as well. So this container creation itself has failed because I'm specifying a non-root user to be used. Next, let's see. I may not be a root user. I may not be a non-root user with a specific user ID. Rather, I can have a permission, a little bit of privileged type of access. And what's the difference between a root access and a privileged access? In root access, you just have the default root options. But if you say privileged, whatever hardwares are there present on the host operating system level, that root is also not having access to. But with this particular user, you should have access to the hardware on the host operating system level as well. How do you specify that? Just say privileged and say true. You should be able to create a pod with a privileged user. Let us quickly create this and let me do an ID and show you the difference as well. And then we would use the ls command and /dev is for the devices we would try to see. So let me pick this name and say ID. So in case you see, I am belonging to the root user, but I have little bit privileged access as well. So when I say privileged is equal to true, I am root, but I have privileged permissions as well. And that privileged permissions, how do you see? I should be able to list the devices which are connected to the host operating system as well. This is the output from the default one. Let us see the output from the privileged one, right? We saw the ID difference. There is no difference in the ID. Both guys belong to the root user ID. But here in the root option, this guy was the default one, the initial one which we created, which as a root user I'm running. But if I do ls/dev, I just see this list and see if I am a privileged user inside this privileged pod, I can access anything which is there on the host operating system. So I have got a privileged set of access. But with the default set of pods, if I try to run any actions like setting up the time or something, I would not be able to do because the time comes from the central clock which is running on the host operating system. I'm trying to execute the date command and I want to set it as 12, time as 12. And that I'm doing in the first initial pod which we have done. It will say that the operation is not permitted because I don't have the access to do. If I want to do such actions, do some network configuration, do some system configuration on the host operating system level, then I should have those capabilities. So here you will have to add that capability. That capability doesn't come by default. Even though you're a root user, you don't have that kernel level access for the host operating system. So you are adding capabilities, you're saying add and you're saying systime. If you execute this pod, which has the capabilities of doing systime, and after that, if you try to set the date and time, let's do that. Let's pick up this pod name, the one which we have created with the access capabilities of changing the time. I'm able to do the set for the time. So here the system time command runs for the container which has the root user itself, but it has the capabilities to work with the system time. This is the way we add the capabilities. In case I want to drop a specific capability, then you can use drop option. Any capability which normally a root user has. A root user inside the container should be able to change the ownership of files. That's a basic thing we can have, right? But I want to drop the capability from the container. And let's do that. I'm trying to create that particular container. I have created that pod and I want to change the ownership of a container which has that removed capability. So here, if I want to execute this command in remove capability pod, and I'm saying change the ownership as guest for /temp, I'll not be able to do. Why? Because I have dropped that particular capability inside that container for the user. So this user will not be able to run the chown or change ownership command. Let's see a few more options. I may mount the file system as read-only as well for a particular container. We had learned that every container has two parts, the read-only part with which it starts, the image, and the read-write layer. The read-write layer is present in the container itself, right? But I want to make the entire file system as read-only. And let me first create and then open the file and show you so that I have the file name to copy and paste. So yeah. So here if you see, I'm creating a container. Till here everything remains same. I'm saying read-only file system is true, root file system. The file system which comes with the container, that is read-only, but I'm also mounting another volume called as my volume, which is not read-only. Read-only is set to false. So I should be able to write this volume, which is an empty directory mounted inside the container, but I should not be able to write to the root file system. Let's do this. We can do a touch command which tries to create a file. Let's do that and see that it would fail because here I'm trying to write to the root file system. In the case you say /volume, which is what I had mounted to, it should allow me to write over here. And it has executed that command without an error. It should be creating a file called as new file. And if I do a ls and see whether the file was created, I should be able to list the file in the /volume. The new file should be hyphen over here. That's the reason it didn't list. Yeah. I have created a file with new hyphen file. So that got created. And that's what I'm trying to list now. And it says it is listing. But on the root file system, it didn't allow me to write anything because I was not having proper permissions to write to the root file system because that was being constrained as read-only root file system. So this was all about applying specific security constraints inside the container so that I'm able to execute some command, not able to execute some command, have a certain level of access on the operating system, or have a certain level of access on the root file system of my container itself. So this way we can reduce the options of breaking some security flaws which are there and applying proper constraints. Whatever sort of actions you want to allow your container to do, give only those sort of permissions or security permissions to execute such type of command. So that was all about the security context. We would discuss about some configuration parameters which we can pass to our containers, and there are different ways in which we can pass these configuration parameters, making it more secure as well and making it more editable or manageable. So when we say it is a configuration parameter, it is some settings which is helping us tune our application to execute better. It is either an environment variable or a flag which changes on some specific logic inside my application. And I don't want my containers to depend on that environment variables. And if there is a change in the value of the environment variable, I'll have to rebuild the entire image. That dependency I don't want to create. Then in such cases, when each of the container has its own environment variable, which are defined in the image of it, if I'm making any changes to its value, I need to recreate the entire image, rewrite the Docker file, execute the Docker build, and recreate the image and redeploy. I don't want to do that. And that was the drawback on the Docker level as well, right? In Docker, if we had to change anything, then we had to rebuild the entire image. To overcome that, if we want to change anything, then there should not be any need to recreate the entire container or modify the deployment. What we would do, we would be writing these environment variables as part of volume or as part of environment variables, which can be run which can be not run, rather changed during the execution itself. So if we wish to change this variable inside multiple containers, I need not have to go to each of the containers and change a variable value. Rather, instead of doing that duplication, I can write the parameters value in a separate file, which is normally called as ConfigMap. And if I change it in one place, it should reflect in each of the container. So we would see there are two terminologies. One is called as ConfigMap and one is called as Secrets. Kubernetes uses these two kinds to solve these problems. Secret is used for confidential data, where we are encrypting the values which we are supplying inside our containers to our application, and ConfigMap is for non-confidential type of data. Any configuration parameters, like we have our nginx conf or any type of configuration which you want to pass. So let's see how does the ConfigMap works. ConfigMap is nothing but a configuration data which is saved in the key value pair, and it can be consumed inside the pod in different ways. So we would create a kind config map, we'll store the data in it, the key and the value, and that particular config map would be used inside the container so that the container gets the value of it. And on the runtime, we would be not going inside the container and changing the value. Rather, you change the config map and that should reflect inside the container. So using this way, we can organize our configuration data in much more easier way. And could be there are 10 containers which have the similar configuration and the same values to be provided. I need not go and change in each of the containers and rebuild the containers, right? I can change it in a single place and that should reflect in each of the containers. So we would see how does this configuration data be used. We can set this configuration data as an environment variable inside the container, or you want to provide it as a command line argument for a container, the arg sections. You can do that as well. Or you can write config files and as a volume you can mount them. There are different ways of using this configuration map. See how do we use config map to set the environment variables inside a container. So we can set container environment variables using config map. So let's understand how does a config map look first. Config map has an API version 1 and kind is designated as config map. Metadata associated with config map, you're giving the name and the namespace. If you don't give the namespace, still here the value is default, so it will take the default namespace. But if you want to create a config map or any type of resource, if you write the namespace section in the metadata, that particular resource gets created in that namespace which you specify. Config map has a key and a value. The data which we are storing is as a key value pair. So here if you see, the data is a key called as my data and the value is called as hello world. This particular key and a value we would be supplying as an environment variable in a pod. So let me quickly create this. I'll create this. Let me show the pod which is using that particular config map. So here kind is pod, metadata of the pod, the specification, the container, the name, the image, the port number, everything as we have been doing it. But this time the env is the new parameter. So I'm setting an environment variable inside the container. The name of the environment variable is called as CM, and the value the value of the CM is coming from a config map key reference. So it is saying this value would be supplied from a config map whose name is myconfig. And which value do I read? My config map can have hundreds of keys. I want to reference only one key, and that value I want to set inside the container. So I'm referring the key of my data. So let's go and quickly refer back. The name of the config map is myconfig, and the key which we are referring is my data. And that's what you are mentioning over here. I'm creating the config map over here using the ConfigMap YAML. You can do a kubectl get on config map. The short form is CM. My config is shown up over here. You can describe that particular config map as well, and you give the name as my-config. You should be able to see the data section too. Now let's go ahead and create a pod which is using this config map. So name is ConfigMap-pod, the file name, the one which we had seen, -pod, and here the pod is created. kubectl get pods. Let's see. Awesome. The pod is also up and running. So now pod is created. How do you find whether the environment variable is set or not? We are executing interactively in this CM-pod which we have created, and we are trying to print the environment variables which are set inside that particular pod. Let's do this. Here CM equals to hello world is set. So what's the advantage of this? Now if I change the value, I just need to recreate the pod. I need not recreate the image for that container. Just recreating the pod would reflect the changes of the config map values in case I'm changing. So this way you can use config map as an environment variable inside a pod. Let's see the other one. Let's quickly clean this. I'm deleting the pod and I'm deleting the config map, both of them. Let's quickly do that. It will take a while for the deletion of the pod. Let it delete till the time we would go and see the next section. So here you are creating one more config map. So either you have a key and a value, or you can write the entire configuration file itself inside the config map. So if you see this config map file, I have data called as Redis config, and it has multiple lines in it. And how do we denote that? With this pipe symbol. I don't have a value associated with it. I have a complete chunk of the section associated with it. Okay, so here Redis config, the data is Redis config, the key, and the values are these two lines. Kind is config map, metadata is given, and the namespace. So we would go ahead and create this config map. Let's see the pod as well, which is trying to access that. So once we are using this config map, we want that config map data to be present in some file inside the container, because that's a content of a file, right? It's a content of actually redis.conf file. So here I'm creating a Redis pod, which has a Redis container. This environment variable is a generic environment variable, which I'm setting the value here itself. There is no value from the key of a config map and all that, rather a standard environment variable. The port opened by the container, the limit of resources by the container, and in the volume mount section, we have two things. If we have a normal volume which we want to mount, that is one thing. And the second, we want to mount the config map as a volume. So we are trying to show both the flavors so that you can differentiate between them. The first one, Redis master data, is mounting a volume called as data. And if you see, data is what? Data is an empty directory. But the second one is /Redis master. The name is config. Let's see, what is it? Name config is saying I'm a config map. I'm not a normal volume like any NFS volume or EBS volume or empty directory type, right? Rather, I'm a config map. The name of the config map and what all items do I want. I'm saying I'm accessing this key from this particular config map and place that in this path as redis.conf. So whatever content we have written in the config map in the redis-config key, that would get written in redis.conf. So let's quickly create this and see what do we get out of it. We would try to access this redis.conf from the container and see the content is updated. So let me quickly pick up the file names. First, let me get the Redis config map, cm.yaml. I'm creating the config map, kubectl get config map. I should have one of it. Let's start the pod, create -f. Sorry, that's -f and give the name. This is also created, kubectl get pods. Let's see our pod is up and running. Yes, it's up and running. Now these two steps are done. You could see that things are up and running. Now we are trying to execute on Redis pod. What we are trying to do, you're trying to cat. What you're trying to cat, because it is mounted in /redis master. Where is this mounted? This is mounted in /redis master, and the file which gets created is redis.conf. So I'm trying to cat the content of this file. Because this is mounting a config map as a volume, it should have those two parameters or those two sentences updated inside the redis.conf file. So with this, you understand that how I want to use, if I want to use a config map as an environment variable, or I want to mount that config map inside the container as a volume, I can even do that. Before leaving from the exercise, don't forget to delete the resources. Cool. All the resources are cleared, so our cluster is clean for the next exercise, just to get all and verify. Cool. So that was all about the config map.
So there are some sensitive information what we have. Like, for example, I have a couple of microservices, and say maybe I have a web UI which is acting as a front end for me, which needs to talk to my database. All right. And what does it need? To talk to my database, it needs to have my database connection string, which consists of my user ID, it consists of my password, it consists of maybe which DB name, some sensitive information. Of course, for me to talk to my database, I need to configure my front end to talk to my backend, my database, to connect to which database, what is the name, where is it running, what credentials do I make use of. I need to specify these connection details, and that's when I can make a connection after authenticate with my database out there, right? And there are a couple of places where we can mention that and we can connect to it. One is I can write this connection string in the code what I'm writing. In the code, I can hard code that connection string as a plain text, or we're containerizing the same application. Maybe, I can put this connection string as part of my image, maybe as environment variables, where I can hard code this. Or maybe when I write my manifest files, YAML or JSON files, I can specify the environment variable values in the YAML file. The problem with all of these three methods is we are exposing our credentials in plain text. Anybody who has access to my code right now, my GitHub, wherever I'm storing my code, knows what the connection string is, right? If I set that as an image, whoever can inspect my image can know what it is. If I put it in the manifest files, in my YAML files, and check in those YAML files in my source control, anybody with access to those YAML manifest files can also read that sensitive information as plain text from these YAML or JSON manifest files. What do we do then? This information is needed from one service to another service to talk to. When I say service, not the Kubernetes service, the microservice, right? To connect, it needs those strings and it needs that sensitive information. And if you put it out there in the plain text format, either in your code or your image or your YAML files, anybody with access to those can read it. So we want to safeguard what our credentials are. What can we do? Kubernetes offers you an API resource called as secrets. What it does, you have your passwords, or your tokens, or your keys, your private keys, your SSH keys, some sensitive information which needs to be stored separately from your environment variables or your configuration, which can be created beforehand, some sensitive information stored in your etcd and made available to that particular pod which needs it during the runtime. That's what secrets are. Has to be less than 1 MB in size, typically made use for your sensitive informations like your password, your tokens and keys. Let me show you one example which we looked at in Docker Compose. If I bring out and if we go to hub.docker.com, one of the example we looked at when we were doing Docker Compose, we looked at one of the most popular Ghost blog application out there. Right, this is what we looked at, a free and open source blogging platform. Scroll down a little bit. It tells you, it's made up of two different services. You have a Ghost UI, and then you have a MySQL DB running out there. Together is that your Ghost application will be out there. We took this example for deploying it on our Docker Swarm using Docker Stack or Docker Compose using the standalone Docker. If I convert the same thing to the YAML file, more or less the same thing in the Kubernetes YAML file as well. If you pay attention and look at it here, the Ghost blog, what we have here, it needs to talk to the MySQL DB. And for it to do so, it needs the host of the database, the name of the database, as which user are you connecting, what password are you making use of. This was put into the YAML manifest file out there. They could have taken this, put it as part of your image, what they're building as well, as environment variable. Of course it is, and this is what you're overriding it. Or you could have built it into the code. But either ways, like we discussed, this would have been in plain text. Anybody with access to that could read it. So the solution, Kubernetes offers you something called a secret. You can make use of that, save and protect the sensitive information. But what we realize here, the Ghost blog, if it needs to talk to the DB, it needs those connection strings. There's no escape from that. So instead of leaving it out in the plain text where everybody can see, we take this sensitive information, we create them as an API resource called a secret, which is stored in your etcd. And when you write your manifest files, you don't have to write your key and value pairs, the environment variables, in plain text. Instead, what you can do, you can write the keys, but the value for them, you can reference it to the secret. So whoever reads the YAML file will not make out what your password is. But when you deploy that secret is already created, stored, and made available in etcd. API server takes that information, passes it on to the kubelet, whichever kubelet needs it, and that is passed on. And when the container is creation as an environment variable, that's what secrets are. Just gave you a little bit of overview summary. Let's go take a look at that in the working, where we get better understanding. Let me increase the font size a tad, little bit, so you guys can see it better. Kubectl, create me the secret, and I'm going to ask for help. It says there are 3 types of secrets what you can create. The first one is Docker registry, generic, as in any information you want to create. Then there is TLS type of secret. Okay, what is the Docker registry secret? Now think about this. Here is the story. I have 100 nodes in my cluster, and I need to pull images, private images. What were we doing so far? I was making use of some images what I had in my publicly available repositories. We looked at Docker Hub. We never had to authenticate. But if there's an image out there in a private repository, coming from whichever registry, we've been looking at Docker Hub by default, whatever registry it is. And if it's a private repository out there, what's going to happen? When you try to pull the image, what's going to do? That Docker is going to come back and complain, hey, listen, I can't pull this image because this is private. You need to authenticate. And how did we authenticate so far? And if you did Docker info, it showed you were logged in as what user, right? And right now, it doesn't show me anything right now. The reason for that is we are right now using our Docker as anonymous. I'm just making use of Docker as an example, just so that you guys can relate to it. Right? It can be any container runtime, anything, that's fine. But the point I'm trying to make is right now my Docker is the user which is accessing the Docker Hub is anonymous, right? So if I want to pull a private image, it's not going to pull. So what did we do? We had to do Docker login. Of course, when we looked at the Docker login and help, we could specify which server we want to connect to. If not, default is what's defined by your daemon. That's your Docker Hub in our case, right? So if I just do Docker login, it's going to ask me my Docker Hub ID. That is Rohan K21. Go through. It's been a while. Come on. Cool. It says login succeeded right now. And what did it tell me? It told me, listen, your password is stored in a config.json file, unencrypted. Yep. So next time Docker daemon needs to go fetch authenticate, it's going to look at this file. It's going to authenticate. Similar to what your .cube/config file we saw, or .aws file when you configure your AWS CLI, .azure file folder, right? Similar story. Under whichever the home directory, whichever the user I was, a hidden folder called Docker and the config.json file. Now, if I go back and show you this file of mine, I'm going to show you and move away from there real quick. This is my credentials, my user ID and my password in the base64 encoded format. That's what Docker daemon is going to look at, and it's going to authenticate with your Docker. So if you go back and do Docker info, now we see we're no longer an anonymous user. We're logged in as a specific user. Now, if I have rights on the private registry, or if I have the collaborator access where I can pull and push, I can download the image. I can create that pod, right? Good. Now we have, this is the process for you to get authenticated with your registry is what we looked at right now. The challenge what we have is we have 100 nodes. 2-node cluster or 3-node cluster what I have, I can manually go log in into every node and I can say, okay, make use of this to authenticate. But when we talk about hundreds of nodes, that's not practical for us to go log in because we don't know where the pod is going to go, right? It can go on node 1 or node 100 too. If I make use of a private repository, what's going to happen? That container runtime on that node needs to authenticate. What is the solution? The solution is here. There's a secret type called as Docker registry. So you can create or store your Docker config credentials. And what did happen? And when you want to pull an image from a private repository, you can specify this credentials and you can make use of a keyword called as image pull secret. And you can specify the secret name and it's going to kubelet will be passed on with that information. And it's going to make use of that to pull the image from your private repository. How do we do that? Well, we'll say I want to create a secret of Docker registry type. I'm going to ask for help again. It's going to tell you what you need to do. It says, listen, this is the usage. Give some name. Type is Docker registry and some name and username, your Docker user password, your email, your server details if you want to, right? Or you can type it out literally, or you can point me towards the Docker config.json file. Whatever the contents of those files will be stored as sensitive information. Scroll up a little bit, tells you the example. Like you can create a secret this way, or you can say from file and refer to your config.json file, right? How Docker registry secret, you'll say from file Docker registry.config and path to that config.json file. It's going to work that way. Let's quickly create one secret. I'm going to quickly make use of this as an example. kubectl, explain me what is a secret. Tells you what is a secret and tells you what kind of fields you can have. Most of the fields, most of the top level resources of all the API objects, what we have seen so far, had your AKMS, right? API version, kind, metadata, and spec. Secrets don't have spec though. What they have is data, where we can specify key value and scroll up a little bit. It tells you what about it is, holds data of certain type, bytes of value, field must be less than max secret byte, which is set to 1 MB. Belongs to the kind as secret, group as core, version v1. A little bit of, we know explain, we know describe, we know get. We're not going to go back to that. Want to see if there are any secrets? There is one. So what happens when you create a namespace? There is a service account which gets created with every namespace. And when a service account gets created, the token, the bearer token of that particular service account is created. and is stored as service account token. When your pod needs to talk to a API server, it needs to authenticate. It makes use of this service account details to authenticate. Now, when we do a describe of a pod, we see something as a token up mounted as a file system. We will get there. I'm just taking you there. All right, good. So now I want to create a Docker config type of a secret. We're going to copy the same thing from here. Say, for example, I want to create a secret of type Docker registry. I will call it whatever I want. My credentials. My Docker username is Rohan K21, and my password is password. Right? It said your credential secret type with the name my credential has been created. If you go back and do kubectl, can you show me what secrets we have in this namespace? It tells you have a Docker config JSON secret called as my credentials. And if I go back and maybe take a look at that right now, can you describe me the secret? Tells you there is some data, does not reveal you what the data is. That's the sensitive information, it is masked from you. But if I really want to, since I am the cluster admin and I have the role-based access control to do whatever I want to do, I can also do an edit of this and I can look at that secret. So how do you prevent anybody else looking at these secrets is by making use of appropriate role-based access controls. Now we have created some secret. This secret contains my Docker configuration, basically my username and my password. Now I want to create a pod which pulls an image from my private repository. So how do we do? Well, we go back to our documentations and we say Kubernetes docs and we say image pull secret. Gotta choose the right version though. Scroll down, it tells you a lot of story out there. It also tells you when you create a pod manifest. So what do you do? Under your pod spec, you specify something extra right now. What? Called as image pull secret. In our case, it says registry credentials. What we created was my credentials. So I will, when I create my pod spec, I will pass this on. What's going to happen? That secret is created, stored in my etcd. The API server, whichever kubelet scheduler is going to assign us to any node. On that node, that kubelet needs that information. API server is going to pass on that information to that particular kubelet, and making use of that information, the container runtime on that node is going to go fetch that image for you. Now, irrespective of whichever node that pod goes, whichever node needs that information is made available at the runtime. That is what you make use of. One type of a secret called as Docker credentials, Docker registry type of secret. All right. So we know that this is not the correct credentials what I have. So I'm not going to show you as an example of a private repository. I have pointed to you what you need to do. You need to practice it. Of course, you need to, and you will create your own credentials. From the exam point of view as well, they don't expect you to, sign into some third-party registries, maybe Docker Hub or any other hub, and use your credentials. So in that way, I'm kind of safer, is what I feel. I assume that they might not ask me this type of secret where I need to go outside Kubernetes. Okay, that's a subtle hint. But the point is, we should know how to create it, how to make use of that is the use of it. Good. There were a couple of other types of secrets, like what? There is a generic type of secret, what you can create. Good. What does that generic guy do? Any sensitive information, your password, your tokens, anything in the key value format or contents in your file, you want to be created as a secret. So you can make use of generic as a type. Then I don't know what I need to do. What will I do? Ask for help. There are two ways in which you can create your generic secret. One is you mention it from file. Create a generic secret with whatever name you want. Right? There's an option called as what type. And then the main important point, what I want you to make a note is either create it from a file or create it literally from literal key and value. There are two ways you can create it. One, whatever key and value I wanted. For example, if we go back to our Docker, where did that go? Did I close it? Now, for example, there was key and some value. The key was database connection password. The value was example here, right? I can make use of from literal key and value. That's one way of creating a secret. Then either I say from a file, the sensitive information what I have, the passwords what I have, the tokens or whatever I want to protect is in the file 1234. I've written it in the file. What will I do? I will say, why don't you make use of from this file? And I mention the source of it. Then what is going to happen when you say from file? The file name, the base name of the file, when I say base name as in the file name without the extension, is going to act as the key. The contents of the file is going to act as the value. There are only two ways you can create. If we know both the ways, no matter whatever question they ask you, doesn't matter to us. Right? Good. So how do I create it? Of course, we have some examples right on top here. It tells you how to create from a file. This is how you do it from a file. And this is how you do it from literal. Let's look at this first. And let me copy it to a notepad. We'll make use of the same example. It's telling I'm going to create a secret, generic secret, right? This is the name of my secret called as my secret from literal key value. Key is here, key one. Instead of key, I will the key. It's writing at key one. I will say maybe username is called as dbadmin. Okay, and another key and value, whatever you want to. Password is what I call the key, and top secret at the rate 12345 whatever. So when I created this as a secret, there are two keys and two values, which is created and stored in my etcd. Right? If I go back and do, can you show me? Can you describe me secret with whatever name you've created? It tells you there are two keys. There's a key called as username. There's a key called as password. It doesn't tell you what the content is. Right? That is because it is a secret.